In this video, we will simulate a few APB reads and writes. So you can get the tests, you can get all the code here on GitHub. So it's right here, example 2, go down into that. If you need to, you can install the simulator, iverilog, and GTKWaves with just apt-get, and a couple simple scripts, and GTKWaves to view the waves. So let's get started. Um, All right, so over here, it's very simple to run. /co tab. So that's compiled. It runs a little compile script. I'll show you that in a moment. It's successful. That's great. /ru tab runs runs the virtual machine, essentially the Verilog virtual machine, and you run that, and boom. In this case, it runs through. It finds shows you the times, blink rates. It tells you that like the APB pass it. It does some APB read, and then a write, and then a read, and then it runs blinky, and it says passed, and that's all nice and good. Quick little look at the files is /compile tab return. So all it is an iverilog command. That's the compiler. Specify the output file with a -o, and then followed by all the Verilog files. /r cat /ru tab. This is extremely simple script too. iverilog's runtime engine is called VVP. And so you just specify the VVP file that got generated by the compile stage. And so that's that. And now the GTK wave just VCD. So now let's open up the VCD file. Use a simple little hierarchy. Let's open up here. And so we've got test. We've got a lot of signals there. Let's go down to the dot. Where do we want to begin? I don't want to get swamped with a bunch of rough here. So the standard has all the APB signals starting with a P signal, the P name here. So let's just select, let's grab the clock too, and append that. And now let's open that up. And let's go to here, zoom to fit. Boom. And we can see a little bit of action here. And so let's do a right click, slide over. And here you can see what matched in the display that we were just looking at. Where this guy said he did a read and a write and a read from the APB bus. And you can see some action happening here. And this lines up with the specification that we talked about yesterday in the previous video, where the address here, the W data here, W write. Let's put that up at the top. And the P select here. So this is our test bench is driving P select for, you can see it's for 2 clock cycles. In this time, during this time, the P write is low, so this is a read operation. You can see for those 2 clock cycles, the address is stable at 4, a bunch of zeros and a 7 and another 4. The write data, it doesn't really matter, so it's 0 during these read operations. And during the write operation, you can see that it's stable for the 2 clock cycles. And each one of these APB reads is finished off with a single 1 clock cycle enable pulse that's driven by our test bench. So the test bench is driving all of these signals. P ready, I said, always keep it high. In my case, I'm almost true to that. What I'm saying is that Control W, post instruct mode, is that in my design, I've got it so that during reset, P ready is not ready. So it's low and not ready. But after that, it goes high and it stays high for the rest of the simulation. So that every APB access finishes in 2 clock cycles, which again, I say is really important to keep things simple. Um, yeah, so that's pretty much it right in here. So you can see that all happening. And I'm trying to think. Okay, so it's a right click, drag, and that lets you zoom in. Um, and then the middle scroll wheel kind of scrolls left and right. What happens if I hold a shift? Looks like it goes slower left and right. If I do a control, well, it zooms in and out. Well, that's kind of cool. Control scroll wheel zooms in and out. So that's nice. So anyway, these values then get put into these values will then affect how the blink rate of the blinky block. All right, so I think that essentially is what we want to cover in this video. Now we blasted through it. We covered a lot more in detail on the first blinky video. Um, and that's it.